Hello and welcome to the Reisner Lab. My name is Esther Moore and I'm a final year PhD student here. I work in the biohybrid side, so that's combining enzymes with artificial materials. Here in the lab we work on solar fuels. So this is the process of using sunlight to drive catalytic reactions to produce a renewable fuel. Today I'm going to show you around the lab, so I'm going to show you some of the equipment we use and also our different lab spaces that we have here. Thanks. So here we have our materials bay, which is where we do our device work. So that's the production of photocatalytic sheets and also making devices for the splitting of water into different renewable fuels. This is our dark lab, where we work with all of our really light sensitive chemicals. So here we have our glove box, in which we work with photosystem 2 and also our oxygen sensitive materials. And then this is our shaker, where we prepare our cyanobacteria. And in this lab, we work on photoreforming and synthesis. So this is where we use sunlight to produce value-added chemicals from feedstocks such as plastics or biomass. And in fact, at the end, you can see our new HPLC machine, which we recently purchased. So these two gas chromatography instruments we use to measure our liquid chemical products, such as methanol and ethanol. And then what we have here is our solar light simulator, and this mimics the sunlight to then drive our photocatalyst reactions. And finally, here we have our third gas chromatography instrument, and we use this to measure gaseous products such as hydrogen and carbon monoxide. This is one of our glove boxes, which we use where we have air-sensitive materials. In particular, we use this one with our enzymes such as hydrogenase or formate dehydrogenase, which we then put into our biohybrid semi-artificial photosynthetic systems. So here you can see another one of our solar light simulators, and here we have an experiment running in which the light is shining onto the photoactive catalyst, and this is then producing the chemical reaction to give us our renewable fuel. A lot of our materials processes, including the synthesis of nanoparticles or the annealing of our electrodes, require really high temperatures from 500 degrees to about 1,000 degrees. And here we have the equipment we use to do that. So the tube furnace here is an inert heating device, and then the one below is just a normal oven like you might use at home, except it goes to much, much higher temperatures. So this is our largest solar light simulator, which we use to measure scale-up experiments or lots of different photocatalytic vials at once. And then here we have our flow setup. So what this does is that as the reaction is going, we can measure the products as they are made in real time, and this can give us really crucial information about how the reaction is going and lead us to information about the mechanism of the catalysis. So here we have our fluorimeter, which is just one of the spectroscopy instruments we have, including UV-Vis and FTIR. And we use these instruments in particular to look at our dyes, which we use to excite them with solar irradiation to drive the catalysis. I hope you've enjoyed our tour around the Reisner lab today, and we'd really love to hear from you, so do get in contact. You can find us on our website.